In this lecture, we'll be talking about the concept of expected value. Expected value is an extremely applicable real-world concept, and it deals with these questions. What are the expected winnings or losings of a game, and is a game fair? Expected value is extremely important in the industry of gambling and casinos. As you would probably know, and as a famous saying goes, in the end, the casino always wins. What's meant by that saying is that the casinos have slightly, in all of their gambling games, slightly altered the odds in their favor. Not illegally, but just in a small enough amount that people are still attracted to winning the games because there is a small chance that they could actually win a large amount. But with enough people playing and enough people gambling, the casinos always come out ahead. So let me give you a few examples of what we mean by expected value. Let's say that I propose a game where we're going to roll a die, and if you roll even, I will give you $5, you win $5, and if you roll odd, you will lose $5, or you'll give it to me. Now, if I asked you just what is your gut instinct, is this game fair? If it's a fair die, hopefully you would say yes. Now, if I asked you why you know the game is fair, you would probably have to think a little bit harder. But hopefully, after thinking about it, you would come up with something like this. The probability of rolling an even number, 1/2, is the same as the probability of rolling an odd number, 1/2, and the amount you win and the amount you lose, in this case, are equal. So since the probabilities are both equal and the payouts are both equal, then sure, this is a fair game. But what if I made the game a little bit more complicated? So let's take a look at a different game. What if I say you're going to roll 2 dice and you're going to look at the sum of the 2 dice. If you roll a 7, you win $4. Roll anything else and you lose $1. Is this a fair game? And even beyond the question of is it a fair game, is it a game that favors you or is it a game that favors me? This is a lot more complicated question, and we need to be able to come up with a mechanism, a mathematical process to answer the question, is this game fair? And then even if it's not fair, who does it favor and by how much? That is where expected value comes in. The expected value of a game is an average of, if you played this game thousands and thousands and millions and billions of times and you averaged out all your winnings and losings, what would be the average of all of those games? So it's a theoretical concept, expected value, but it gives you the average, the expected winnings or losings of a game over the long haul. If you calculate expected value and the expected value is 0, then we say that is a fair game. If your expected value is negative, then that is an unfair game and it favors the game maker, not you. If the expected value is positive, it favors you, and it's not fair, but the not fairness is tilted towards you. So let's take a look at this specific game. And actually, before we do that, you need a better explanation of, okay, so maybe you are starting to understand what expected value is, but how in the world do you calculate it? There's some nice examples and definitions in your book, but let me try to simplify for you a definition in your book. In a game, there's 2 things that you need to care about. One is all of the possible outcomes. The outcomes in this case are that you win $4 or you lose $1. There's only 2 outcomes in our game. And you also need to care about what are the probabilities of all of those possible outcomes. In most games, you have to calculate that. Although now, after doing a couple of sections, you should be able to calculate those probabilities. The expected value of any game is the multiplication of the outcome and its corresponding probability plus the multiplication of the next outcome and its corresponding probability, so on and so forth until you cover all the outcomes and the probabilities. Now, to make that a little bit more concrete for you, let's actually do it in this example. Okay, so let's write it, before we go to numerical terms, let's write it in words so you can see this and hopefully take it all in. So the first outcome is that we win $4, and we need to multiply that by the probability that we win $4. Well, what is the probability that we win $4? How do we win $4? Well, that occurs if we roll a 7. So that's times the probability of a 7. We're going to add that to the probability, our next outcome, times the probability of our next outcome. So what is our next outcome? Our next outcome is lose $1. And we're going to multiply that by the probability that we lose $1. How do we lose $1? We roll anything else. So I'm just going to abbreviate roll else. Now, when we actually go to calculate this, we're obviously going to insert numbers here. This calculation, though, is going to give us our EV, our expected value of this game. So, the expected value calculation would look like this. Whenever you're winning something, you want to put that number in positive terms. So, in this case, just a 4. The probability of rolling a 7, I'll spare you actually going through that, but that's something that you could look at back in the book. There's a dice chart. It's actually 1/6. So the probability of rolling a 7 is 1/6. Now, we need to add that to, when you are losing money, you need to make sure, this is a common mistake, that you put that number as a negative. So instead of putting 1 here, I need to put -1, representing that I'm losing money. The probability of rolling anything else, you could use a previous concept we covered called calculating the probability of the complement. But if rolling a 7 has probability 1/6, then rolling anything else has probability 5/6. If you multiply that all out and you simplify, you're going to end up with 4/6 minus 5/6, or -1/6. -1/6 is the expected value in this game. But you may be asking yourself, and rightly so, but if you can only win $4 or lose $1, how did you arrive at a fractional number? You have to remember that expected value is a theoretical concept. It's the average of all the possible winnings and losings. Okay, so what do I mean by that? Well, if you win $4 one time, but then you lose -1, you lose -1, you lose -1, you lose -1, and then you win, and if we were to continue with that on and on and on infinitely, and we were to average all of these results, the average would get closer and closer and closer to -1/6. But how do we interpret that number? If the expected value of a game is negative, we say that that expected value favors the game maker. So it's not a fair game, and it doesn't favor us. So if you were asked to play this game, this would not be a good game for you to play, because on average, since the expected value is negative, you are going to lose money in this game. Now that you've gotten a little better understanding of what expected value is, I'll record another video that gives just strictly an example problem of calculating expected value.